Okay guys, so today we're going to talk about the definition of an integral as an area of a region. So essentially, I'm going to draw this picture, then I'm going to erase it and give you the definition. Essentially, we have some random graph of some sort. And I want to see what happens from this point, we're going to call it A, to this point, we're going to call it B. And I want to talk about what happens underneath it. Because integration allows me to find the area underneath the curve, just like as if I were trying to find the area of a two-dimensional shape. My curve is considered to be a two-dimensional shape. It's just not something that's easily able to be like its length times width. This is what we use calculus for. So here is our definition. Sorry, I got the washing machine going. Sorry if you hear that. Okay, so if f is continuous and non-negative on the closed interval a to b, then the area of the region bounded by the graph, the x-axis, and the vertical lines, x equals a and x equals b, is given by area is equal to the integration of a to b of f of x dx. And we'll talk about what that means here in a moment. This brings us to two special cases when dealing with integration. The first one says that if f is defined, we're going to try something else that's a little wonky. If f is defined at x equals 0, excuse me, x equals a, then we define the integral from a to a of f of x to be equal to 0. Now what that's saying is, if I have the integration, and here's my coordinate of a line, there is no two-dimensional shape here. You're only talking about one specific time, and the area about one specific time is just going to be 0. Case number 2 says that if f is integrable on my closed interval a to b, then we can define the integral of b to a of f of x dx is equal to the negative of a to b of f of x dx. So in this case, on my coordinate grid, I have some function. We always go a to b We like to be consistent, so we go in alphabetical order, just like we do numerical value. So typically we're going from A to B, but if it's asking me to go from B to A, we're going to go backwards. So because we're going to go backwards, we need a negative sign, because it's the opposite of what we're used to doing. Alrighty then. This leads us to the additive interval property. It says if f is integrable on the 3 closed intervals determined by A, B, and C, then the following happens. The integration from A to B of f of x dx is equal to the integration from A to C of f of x dx plus the integration of C to B of f of x dx. Now what that looks like is, say we have, again, some coordinate grid. And my graph is, going looking like this, and then all of a sudden it changes and goes constant. Well, since my function changes at a specific point, and we're looking from here to here, since it changes at this point, it makes sense to just find this area, and then add them together. Woo! Properties. I'm going to scoot these down because I can give myself enough room. So if f and g are integrable on a comma b, and k is a constant, then the functions of f times, the functions of k times f and f plus minus g are also integrable on a comma b. And the following happens. My first says that if I take the integration, okay, let's try again. If I take the integration from a to b of k times f of x, it's working so well. Dx. Oh, I may have my k there. So one more time. A to b of k times f of x dx. It's the same thing as saying k times the integration from a to b of f of x dx. So talking about that constant rule, like what we did a couple days ago when we first talked about integration. Likewise, if I'm taking the integration of a to b of f of x plus minus g of x, I can just go ahead and split those up. Take the integration of f of x dx plus minus the integration from a to b of g of x dx. Okay, so what we're going to do is we're going to start, and I'm going to make this smidge thinner so I can fit everything here. We're going to go ahead and start by first taking the integration. And we know we can pull out constants and all that good stuff. So I'm going to pull out my constant of a -1. Take the integration from 1 to 3 of x squared dx plus 4 integration from 1 to 3 of x dx minus the integration of 3 dx from 1 to 3. Once I take that integration, that gives me negative times x cubed over 3. x cubed over 3. And I'm going to evaluate that between 3 and 1. Then I'm going to take that and I'm going to have 4 plus 4 times the integration of x squared over 2 evaluated between 3 and 1. And then I'm going to take minus 3x of 3 evaluated between 3 and 1. So when I say evaluated, it means I'm trying to find what happens in the middle. When I find the integration from 1, it gives me all the way up until 1. When I find the integration until 3, finds all the way to 3. I want in between them, so I end up subtracting them. So I have negative sign of 3 cubed over 3 minus 1 cubed over 3. That's 4 times 3 squared over 2 minus 1 squared over 2 minus 3 times 3 minus 3 times 1. Three squared gives me 27 over 3 minus 1 over 3 plus 4 times 9 over 2 minus 1 over 2 minus 9 minus 3. Which gives me 27 minus 3 gives me 26, times the negative gives me negative 26 over 3. 9 minus 1 gives me 8. 8 divided by 2 is 4, times 4 is 16. 9 minus 3 gives me 6. I'm going to put that whole bad guy together. The area of that is 4 over 3, or essentially 1 and a third. So not terrible. Let's take a look at the integration of this guy. So I'm going to take the integration of 5, which is going to give me, 5x, because I'm taking with respect to x, so I'm sticking the x on. I'm going to evaluate that between 5 and 1. So I have 5 times 5 minus 5 times 1. 5 times 5 gives me 25, minus 5, which gives me 20. Alright, again, another little simple problem. So the integration of x is x squared over 2, and I'm evaluating that between 3 and negative 1. So I have 3 squared over 2 minus negative 1 squared over 2. 9 over 2 minus 1 over 2, which gives me 4. Alright, so we should be getting pretty good with our integration now. So we should know that I'm going to get 5x cubed over 3 plus x. I'm going to evaluate both of those pieces. I forgot to write this in my spot. Between 0 and 5. So when I go and do that, I have 5 times 5 cubed over 3 minus 5 times 0 cubed over 3 minus, plus, 5 minus 0. 5 to the third is 125. Times 5 more is 625. Anything times 0 divided by anything times 0 is 0. Divided by anything is 0. And then 5 minus 0 is 5. Gives me 640 over 3. that's all I got for you. See you tomorrow.